We demonstrate a novel means of antiviral drug discovery, avoiding both host toxicity and viral resistance development by targeting the subset of cellular host factors essential for viral replication rather than the conventional strategy of targeting the virus itself. A complex library of drug-like small molecules was screened in a sandwich ELISA in the presence of host factors. Only fully assembled virus capsid gives a strong ELISA signal, whereas potential drugs interfering with host factors leads to a decreased signal. We identified lead compounds with nanomolar activity against influenza virus. Remarkably, we did not observe development of resistance when passaging influenza virus in the presence of our host factor targeting drug, while virus targeting oseltamivir rapidly lost antiviral potency. Efficacy was observed against all 6 viral families causing most human respiratory tract disease, including influenza, RSV, rhinovirus, and SARS coronavirus 2. The drug target was identified to be a small subset of the host protein 1433 within a transient multi-protein complex. We conclude that selective targeting of the subsets of host proteins recruited by viruses for capsid assembly can lead to powerful drugs that avoid host toxicity by restoration of cellular homeostasis. Development of one drug effective against all major respiratory viruses enables a new respiratory therapeutic paradigm. Early treatment upon onset of mild upper respiratory tract symptoms to prevent progression to serious lower tract disease, viral pneumonia, regardless of viral cause, be it a pandemic virus or the common cold.